Welcome. In this chapter, we will look at how to work on patterns in programming. So first, let's start looking at this simple pattern, a right angle triangle pattern. For a given value of n, when n is 4, it has to print this pattern, right? With starting with 1 asterisk to 4 asterisks. When n is 5, 5 rows should be there. This is a very simple pattern. First, let's start with this pattern and see how to go about it. As a normal user, you look at this pattern as a asterisk followed by a space and asterisk, right? So we have to print 4 asterisks, 3 asterisks, 2 and 1. That's how as a normal user you look at it. But a computer looks at it slightly differently. It's an asterisk followed by a space followed by an asterisk. Asterisk, space, asterisk. So for a computer, there is a space that is being printed in between the asterisks. But when you look at it like a normal user, you look at it slightly differently, which is like you don't see the spaces, right? You just look at it as the asterisks have to be printed. So there is a big difference between both. Let's look at how to program this. So while doing programming, remember that the computer always looks at it in a horizontal way. That is, you will not be able to print it like this. This is not a way you can approach programming for patterns. So why? Because in a computer, when you print it on the screen, you cannot print it like this. I mean, this is an approach which cannot be done. Instead, the approach that has to be followed is one row at a time, right? This is the way the computer can print. The computer cannot go back and do it vertically. So printing it from here, one below the other, next row, next column, third column and fourth column is not possible. You have to print in the computer screen one row at a time. This is very, very important when you try to solve a pattern program. So now let's look at the logic here as to how to go about it. So first remember that the n, value of n is very important. So here the value of n is 4. So there are 4 rows here. So there should be a for loop which will control the number of rows, right? Usually it's called the I loop. And then there should be a for loop which will control the number of columns, right? That will be called as the J loop. Now let's start approaching this program. Here we see that there are 4 rows. So there are I loop has to run from n is equal to 1 to n is equal to 4. So first the program would start like this for I is equal to 1 to n, right? So don't start from 0. In this case, start from 1 when you do for patterns. 1 to n. So totally 4 rows are there. So the value of I, which counts the number of rows, runs from 1 to n. Second is to print for the columns. So the J column runs for the first time it has to be 4. Second time the column has 3. Third time the column has 2. And the fourth time the column has 1. Let's see how to do that. So when I is 1, the number of columns in J is 1. When I is 2, for the second row the number of columns is 2. For the third row the number of columns is 3. And the fourth row the number of columns is 4. So this would be in the loop you would do it as for a J is equal to 1 to I, right? So when I is 1, J will be running to 1. When I is 2, J will be running to 2. When I is 3, J will be running to 3. When I is 4, J will be running to 4. Next would be to print the character. Let's assume we are printing the star and space, right, together. And after that, for at the end of every column, you have to have a new line so that it comes to the next line. This is not a program. I'm just coding a general algorithm. You can use this for any programming language. So for J equal to 1 to n, for I equal to 1 to n, for J equal to 1 to I, print star and space, right? Now let's look at this in C programming. So let's write a C program in online GDB for this. Int main, int n is equal to 4, I comma j, right? 2 loop variables. So the I loop we saw that has to run from 1 to n, and j loop has to run from 1 to I, and then we are printing the star and space here and then printing a backslash n. So if you run this program, you see that the stars are getting printed correctly, right, as expected. But let's do one small check here, right, from what was our requirement to what is here. So when you look at this requirement to what you see here, it seems perfectly fine. It looks fine. There is one small problem here. Let's look at it in greater detail. So when you look at the spaces, right, in between Ideally, this is what was the requirement. There should be one space between the asterisk characters. Now in the same program, let's type the B and see whether the spaces are exactly aligning. So in this program, I'll make one small change here for the spaces, right? I'll run it again. So now if you see, there is a slight mismatch. This last row here that you see, there is an extra space. I mean, this B is representing the space. When it was a space, you did not see it. But now when you see it as a B, you see that there is an extra here. So this was the requirement. Here, when you look at it with the space, you see this, there is no space, extra space here. There is no B here after this, right? This B is not there in the requirement, right? But in your code that has been written here, we see that there is a extra B. Now, how do we remove it? So here, both the space star and the B were printed together. Let's knock it off. We'll print one at a time, right? So here, let's make a slight change here. So now when you do it, when you split this into two, always split it. So when you split it like this, now you have a better control of when to print the B, when to print the star. So we have to print the B when the last B, when the value of j is not equal to I at that time. So when the value of j is not equal to I, only at that time we should print B. So what will happen is this last B here that you see should get eliminated. So let's run it now. You will see the code. Now this is perfect. This is same as the requirement. Now replace the B with the space which was the original requirement. So now you see that yes, the space, extra space is removed. So when you saw it as a B, you saw that there was an extra B. Now actually it fits. So why this is very important? To control the space separately from the character rather than printing them both. The main reason is if you control the space with a separate printf, now you can easily control it with a command and you can avoid it wherever it should not be there. So always, even if it is star and space, don't give it here. This will, I mean, you will not be able to control them. Now if you have it like this, now you can control it separately. So this is a very simple program. It gave a good introduction to how to approach patterns. Let's look at a little complicated one. So let's look at a slight change to the requirement. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For n is equal to 4. Instead of stars, now you have the numbers, right? The logic doesn't change much. Let's look at the program now. So let's first look at the algorithm. So we need a variable called count, which will be incremented every time. So here, this algorithm does not change because the number of rows is still 4, right? Or equal to n. And the number of columns also does not change. It is 1 to I. First row has 1 value, second row has 2 values, right? Here what we print will be the count, and after every time the count is printed, it has to be incremented. So it is done within the j loop so that it gets implemented. Let's look at the C program for the same now. So the C program looks like this. So you have a variable count now which is initialized to 1. No other change here. We are printing the count, right? And then we are incrementing the count within the j loop. So now what happens when we run this program? This gives you the expected output. So this is a right angle triangle number which is pyramid which is getting printed. So now let's look at a newer requirement where instead of numbers it is letters A, B, C, D, E, F, G, H, I, J. Now how do we change the program for that? Let's look at that now. Remember the key is ASCII. There is ASCII table. In ASCII table, the value of A, capital A is 65 and B is 66 and it goes on like that. And lowercase a is 97, right? These are the two things to remember. So in this program, only small change here is we will do a %C and 64 plus count, because count is 1. It starts with 65 here. That's the only change required to this program. So when you print that, it will print A, B, C, D, E, right? Now even if you increase the value of n to 5, it will print the next set of numbers. So very slight modification to the same code, it will print the value. So now you can see that A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, right? So this is how you get the printing done. So remember the magic is 65 when it is printed as %C, it will print capital A, right? So that's what we have done here. Now let's consider a case where it's in the reverse order, right? Still 4 rows, but first row has 4 values, second has 3, third has 2, and fourth has 1. The pyramid has inverted, right? So the I loop still remains the same because it has 1, 2, 3, 4 rows, but the number of elements in each row changes, right? The number of columns. So the first row has 4 columns, second row has 3 columns, third row has 2 columns, and fourth row has 1. So the J loop, which controls the number of column, has to be inverse. So when I is 1, J has to be 4. When I is 2, J has to be 3. When I is 3, J has to be 2. When I is 4, J has to be 1. Now we know that N is equal to 4, right? This is the value we know. So for the J loop, it has to first, when I is 1, so the value of J has to be calculated like this. J is equal to N minus I. When you do this, it comes to N is 4, I is 1, so it comes to 3, but we need 4, so we'll do plus 1, right? So J has to start here. Then next time when I is 2, let's see if this logic works. N is 4, 4 minus 2 is 2, 2 plus 1 is 3. Perfectly works here. When I is 3, N is 4, 4 minus I, 4 minus 1 is 3. Oh, sorry, 4 minus 3 is 1, 1 plus 1 is 2. It works. When I is 4, 4 minus 4 is 0, 0 plus 1 is 1. So this logic works. So remember this is the formula when you have to do it in the reverse order. N minus I plus 1. The key is to establish a relationship between N and I so that you can control the number of columns. So let's see how this logic works now. So this is the change to the program. It starts from N minus I plus 1. Now J has to be greater than or equal to 1. We had less than or equal to N. Now while it has to reduce every time, so till the value reaches 1, right? J reaches 1, you do a minus minus J. Every time you reduce the count here. Now the other thing we see is when J not equal to I, this becomes J not equal to 1. Because only when it reaches 1, you stop printing the star. So let's run this program now. So it is 4, it starts next 3, 2 and 1. And when J value of J is now 4 here, 3 here, 2 here, 1. When it reaches 1, you stop printing the extra space here. So here it was J not equal to I, we changed it to 1. So that whenever J reaches 1, you will not print the star, otherwise, or you will not print the space, otherwise you will print the space here. So this is the logic, this is how you do the reverse ordering as well. Now let's look at this pattern where there are 3 spaces followed by 1, 2 spaces followed by 1, 2, 1 space followed by 1, 2, 3, and no spaces followed by 4. So here when you look at it, when I is again going to run from 1 to N, right? So no changes in I loop. In the J loop, you see that when I is 1, when I is equal to 1, right? J loop has actually 4 columns, but there are 2 parts here. One is for the spaces, one is for the numbers. So let's first look for the spaces alone. So for the spaces, when I is 1, J is 3. When I is 2, J is 2. When I is 3, J is 1. When I is 4, J is 0. So basically the change here is J loop is equal to, the change that we make is J is equal to N minus I. So this is the change that we'll have to, this is the way we'll determine I. So when N is 4, J now is, so when I is 1, 4 minus 1 is 3. When I is 2, 4 minus 2 is 2. When I is 3, 4 minus 3 is 1. When I is 4, 4 minus 4 is 0. Next comes the numbers. So numbers is straightforward. When I is 1, J, the number of times J has to print is 1. When I is 2, J is 2. When I is 3, J is 3. When I is 4, J is 4. So a straightforward one, I equal to J. Now let's look at the program. So here we have made the program. I is 1 to less than equal to N plus plus I. j is equal to 1, j less than or equal to n minus I plus plus j, spaces are printed, j is equal to 1, j less than or equal to I plus plus j, and print this. Let's run this program. So here you get the pattern that we look for. So this is the third one where there are spaces followed by the numbers. So far what we saw is all one quadrant pattern. Now first time we will look at a two quadrant pattern. In a two quadrant pattern, so far we saw this half alone, right, was there in the pattern. This is called as the first quadrant. Now you see the second quadrant, which is a mirror image of this. Usually these are called two quadrants. I mean, sometimes there might be space separating them. Sometimes you might not see the space separating them. How do you approach two quadrant patterns, right? So here the key is, remember that you cannot print the first pattern and go for the second pattern, because the first quadrant, the cursor will be here. C will not be able to go back here, right? Any programming language cannot go back. So what you will do is you will print the first row in the I loop for the first pattern and the second quadrant as well. And then you go for the second row, you print this for the first quadrant and then for the second quadrant, this for the third quadrant, first quadrant, and this for the second quadrant, and this for the first quadrant, and this for the second quadrant. So now let's look at the program for this. So you see that within the I loop itself, the first quadrant code is there and then the second quadrant code is there. So when I is 1, it will print the first row of the first quadrant and first row of the second quadrant, and then I becomes 2, first quadrant, second row, second quadrant, second row, and then I becomes 3. Now third row, first quadrant, third row, second column, I becomes 4, fourth row, first quadrant, fourth row, second quadrant. So that's how it gets printed. Now the changes, this part of the code has not changed. So we saw that between the two quadrants there was a space, so the printf is added here. But after that comes the second quadrant. So in the second quadrant you see that the order of spaces and the numbers has changed, right? So here space was there and then the number. Here actually the number followed by the space. So you saw that print here where it showed that the spaces were first there and then you had the numbers. So here we had, yeah. So spaces followed by numbers, numbered followed by spaces, right? That is the difference between the first and second quadrant. So in your logic, the only change is this loop has to come above this loop. So we have the number loop printing first and then the spaces. That's the only change required. So now when you run it, you see the first quadrant getting printed, second quadrant getting printed. So this is the approach to the first and second quadrant. Sometimes they might even change the pattern to say that this has to be letters. So simple change, right? You can change it to letters here. Nothing else is required. The first quadrant will be numbers and second quadrant you can easily change to letters. Let me just make the simple change here. So now you see the numbers in the first quadrant and you have the letters, alphabets in the second quadrant. So this is another way you might get the programs, right? This is the first and second quadrant. Now let's look at programs with the third quadrant and fourth quadrant as well. Now let's look at this 4 quadrant pattern. This is the first quadrant. There is a quadrant separator with a space here. Second quadrant, third quadrant, there is a space here, and then the fourth quadrant. So let's see how to approach it. Each quadrant you approach it separately, right? Just remember that this requires one I loop. I starts from 1 to 4. Within that I loop, you should have J loops which will help print this. So one J loop for the spaces alone, one J loop for the numbers, and then a printf between that, third J loop for the letters, and fourth J loop if required for the spaces or any other character. In this case it's a space. It's not required here. There are no spaces to be printed, but if they give you a space, 4 J loop will be required. So for this you need for this space J loop, one more J loop, a space here, another J loop, another J loop, followed by there is no quadrant separator between quadrant 2 and 3 and 4. So 1 and 2 is 1, 3 and 4 is 1. So you will run another I loop very similar to how you did for the first two quadrants. These two quadrants you have another I loop. So here there is spaces, so you need stars, one J loop for this, another J loop for these spaces, then you have a quadrant separator, then you have another J loop for the spaces, and finally one more J loop for the letters. Now let's look at the program in action. So this is the program. So let's look at this. So you have the first quadrant where you have first the spaces followed by the digits. So this is one I loop. Then you have a quadrant separator, which is a space. Then you have the letters followed by the space. After that you again have a \n. So by this time the first half of it will get printed. So this would be printed by now. Then you have the stars followed by spaces in the third quadrant. So again, if you look at it, the same for loop has been repeated here, I loop. So here the third quadrant is printed, I is equal to 1, less than I, plus plus I, j plus plus. You print the star followed by the spaces. Then the quadrant separator is there followed by the fourth quadrant. So here one thing to notice, when you look at this, j less than or equal to I, 64 plus I have given here. Here 64 plus j. The difference in the output that you will see is, in the first one it will print AAA, because within this loop the value of I is the same, j only changes. So 64 plus 1, 65. So in the second quadrant you will say A, B, B, C, C, C. Here actually I am printing 64 plus j, which will print A, AB, ABC, ABCD, right? So in the fourth quadrant you will see that. Let's run this. So here you see A, B, B, C, 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 D, 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 because the value of I is printed. Here given that j is printed, A, AB, ABC, ABCD. So this is how you approach the patterns. So quick thing, first check the number of quadrants. Most probably there will be only one quadrant, but if there is more than one quadrant, you know how to approach it now. Good luck.